Hi friends, welcome to follow up. Let's have a look at problem 1376, time needed to inform all employees. This is today's daily challenge problem. In this video, we're going to explain a solution based on traversal. So here we have a company which has n employees with a unique ID for each employee from 0 to n-1. And the head of the company is the one with head ID. So every employee has one direct manager given in the manager array, right? So manager I is the direct manager of the ith employee. So the manager of the head ID will be -1, right? So it's guaranteed that the subordination relationships have a tree structure, right? So here it specifies that this problem we are working with a tree, a special type of graph. So the head of the company wants to inform all the company employees of an urgent piece of news. He will inform his direct subordinates, and then they will inform their subordinates, and so on until all employees know about the urgent news. So notice that we need every employee get noticed. So the ith employee needs inform time I minutes to inform all of its direct subordinates. Right. So here we are required to return the number of minutes needed to inform all the employees about the urgent news. So here we have two examples. These two examples are not very representative, even example 2, because we can have a longer path of notice, right, or report chains. So in example 1, so this is a very special case, so the output is 0, so there's nothing to explain. So for example 2, so we have one head, we have all the other employees are his or her subordinates. So the inform time for the ID 2 is 1. So the output for this one is 1 because it just have one level, right? So here are the constraints. Here we have information time equals 0 if employee has no subordinates. In the graph language or in the tree language, it means that the corresponding employee is a leaf node. And it's guaranteed that all the employees can be informed, right? So in other words, it's indeed a tree structure. So with that said, basically we are ready to do the coding. So here we are going to use traversal. And in this problem, due to the tree structure or due to the report relation, it's a direct graph, right? So for this problem, basically we want to find the maximal time to inform up to all the leaf nodes, right? That will be the maximal will be the result for this problem. And for the coding, I'm going to first build the graph or tree in this problem. So here I'm going to use graph. Let's use collections default dictionary. So let's default the container to be a set, and then we are going to, so for the person and the manager, in enumerate manager, right? So if the manager is not -1, right? In other words, we have an edge from M to P, right? So we're going to do this graph M edge P, right? So this will give us the relationships or give us the tree structure in this problem. So next we are going to do traversal. Let's do breadth-first search solution. Right, so we have a result, so at least 0. Let's use this as initialization. And then we're also going to use a deck or queue. So here is a list. Let's first put the head ID, right? And the time the head ID needed to inform its subordinates. So that's inform time head ID, right? So that's basically about it. Now let's do the standard while loop. So while queue. First, let me get the node or the current. So here we use node as we think of this as a graph, or we can actually make a correspondence between employee and node. So then the time to its report will be q pop left, right? So typically, if in a graph, if we want to do traversal, in order to avoid repetition, we typically do something like this: visited is set, and then we check we haven't visited. We include we haven't those nodes that we haven't visited. But for this problem, because it's a directed graph or a tree structure, we don't need the set, right? So here, let's first get its report. So it's post this graph node, and then we're going to check if the current node is a leaf node or not, right? So basically, if not reports, it means that it's a leaf node. Then we're going to update the result. So this is an important logic here. So we're going to update to the previous state of result and the current time to report. As the problem assumption specified, if not report, in other words, if the node is a leaf node, the time, the corresponding time for here informed time will also be 0 actually. So this is the one. Another one is that if we have neighbors, in other words, so this node has direct reports, and then we are going to check for neighbor in reports, right? So then we're going to append the corresponding information. So here we are going to append this is a neighbor, and then the time would be time to report plus the time the current node inform this neighbor. That is inform time neighbor. So here just make a small correction. So here we need to add the inform time, the neighbor, to its possible direct reports. So with that done, basically that's the main logic. So afterwards, we compared all the times to arrive at each and every leaf nodes. So then we are going to get the desired result. So now we just need to return the result itself. So this short code forms a solution to this specific problem. So before we make any comments, let's first do a test. Head ID. Head ID is not defined. Do you mean head ID? Let's see here. Yeah, I guess it's a capital letter. Yeah, it passes one test case, that is example 2 here. So now let's look at the generic case. Yeah, it passes all the generic cases. So that's basically about it for this specific problem. And here for this problem, so actually the identification of a graph problem is very obvious because of the second paragraph, right? So here we are using breadth first search based traversal. You can also try depth first based solution. So you just need to use pop here, and then you use append here. With that said, basically that's about it for this video. Thank you.